Hello, everybody. It's time now to learn how to determine an empirical formula from percents or masses. That's right. What the heck is an empirical formula? I don't think I need to define that right now. Maybe that'll come up later. What I want to do is get into the process of how to do this because it is somewhat complicated. You'll probably find this to be the most challenging thing that I've taught you so far. So hold on to your hats and get ready to go. Okay? Let me explain what the purpose of these problems is. Last week, I taught you how to do this. I taught you how to take a formula, right? When given a formula, I taught you how to calculate its percent composition, right? Like HCl, hydrochloric acid. If given that formula, you learned how to calculate the relative percentage for hydrogen in that compound and for chlorine. Sorry, a little oops there. Today, I'm going to teach you how to do the opposite. That's right. You'll be given the elements for a compound as well as their percent compositions. Okay? And then your job will be to determine its empirical formula. In other words, it's the reverse of what we did up here. Up here, you were given a formula, you found the percents. Now you're going to be given the percents, and your job is to find the formula. Your job is to find what little subscript belongs after each element in the formula. One thing I can tell you right off the bat is this: is that I will always present the elements to you in the order that they will appear in the compound. H is listed first here, it'll be listed first there, so on and so forth. What will you need in order to do this? Well, you'll need your good friend, the calculator, your classic good friend, the periodic table, and what you should have nearby is a copy of the step-by-step procedure, how to determine an empirical formula from percent composition or mass data. And a copy of this is going to be put onto Google Classroom, so you should have that nearby. And when you're practicing, keep these steps in front of you and follow them with every example that you practice. Okay. So here we go. It's now time to learn how to do this. There we go, coming into focus. All right. So here's a given problem. It's the same one on the last page. We have a compound whose percent composition is this. Hydrogen come in at this percentage, chlorine roughly 42%, and oxygen roughly 56%. The focus is crazy. I wish I knew how to wrestle with this. If any of you know how to deal with focus better, please tell me. All right. How do we then solve this? How do we get from percents to a formula? Well, the first step is to list all of the elements. Okay, hydrogen, we got chlorine, and we got oxygen. And we're going to list next to them their percentages, but we're going to cheat a little bit. We're going to rewrite the percentages, but we're going to rewrite them as grams. That's right. No math necessary. Literally change the percent signs to grams. Sounds like cheating. I guess it kind of is, but not really. You are allowed to do this, and you should do this. And some other time, I'll explain why it works, but not right now. There you go. That's all you got to do for that first step. Pretend that we're looking at masses of each of these elements rather than percents. Secondly, we're going to convert these masses, these grams of each element, into moles. Hey, we learned how to do that in a previous video. How do you change from grams to moles? Well, you would divide each of these by their formula masses. So I'm going to divide hydrogen's mass by hydrogen's formula mass, which according to the periodic table is 1.01 grams per mole. How's that coming out? A little bit blurry. Sorry about that. All right, for chlorine's formula mass, 35.45 grams per mole. And oxygen's formula mass, 16.00 grams per mole. All right. So another thing to keep in mind in this step is when you do these calculations, changing into moles, the answers that you get, you should not be so quick to round them off. You should leave 4 or 5 decimal places because that will help with future parts of this calculation. So 1.19 divided by 1.01 comes out to 1.17822. I'm going to leave 5 decimal places. For chlorine, we get 41.97 divided by 35.45, and that's going to give us 1.18392. And for our friend oxygen, 56.83 divided by 16.000 is going to give us 3.55187. There we go. Nice. I've left 5 decimal places each time because this will produce more accurate things. Wonderful. Step 3 is now we're going to change these numbers into what's called a whole number ratio by dividing each of them by the smallest. That's right. So let's look at these 3 results here. Which one is the smallest? That's our smallest one right there. So we're going to divide each of them by that. So we're going to divide 1.17822 by itself, 17822. We're going to divide this by 1.17822, and we'll divide this last one by 1.17822. Clearly, this one will come out to be a big fat 1. And that's great. We want whole numbers. Whole numbers are what go into formulas. Those are the things we want. Okay, let's work out this one here in the calculator. These 2 numbers look really close to each other. 1.18392 divided by 1.17822. It's going to give us, look at that. Let's see if I can move that closer. 1.0048983 blah 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 blah. 1.004, 1 4 thousandths. I am going to round that off to 1. That is really, 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 really close to 1. And so I'm going to round that off to 1. It's supposed to be a 1. And let's do the last one here. 3.55187 divided by 1.17822. Shaboom. 3.0146 blah blah blah. Here we are. That's really close to 3. I'm going to round that to 3. The object of doing this is to take these percentages and turn them into whole numbers, because whole numbers are what become subscripts in formulas. And it's whole numbers that can be placed into this formula in place of these question marks to give us an answer. So now we can get an answer. So hydrogen will get the subscript of 1, which just means H. Chlorine also gets a subscript of 1, so we just write Cl. And oxygen will get a subscript of 3. And there we go. We got us a formula, ladies and gentlemen. HClO3, aka chloric acid. When you try these problems, you can check your own work by simply coming up with the answer and then on another piece of paper, determine the percent composition the way that we learned last week. If you determine the percent composition and you get percents extremely close to these up here, then you've done the problem correctly. Please go to the second video where I'll have a second example that has, a very important nuance and a variation which you must see and understand.